Hello, physics lovers. Welcome to my YouTube channel, PhyZiVibes. Today we are going to discuss a very interesting problem, that is motion of charged particle in both electric and magnetic field. So here is our problem. So consider a electric field, uniform electric field acting along y-axis and a uniform magnetic field acting along z-axis. So this is electric field along y-axis. This is x-axis and this is a uniform magnetic field acting towards z-axis. Let it be B. Now we have a charged particle Q of mass m which is at rest at origin. Now we are going to analyze motion of this charged particle in this uniform electric and magnetic field. So as we know, magnetic field exerts force on charged particle only when it is in motion. So initially, since charged particle is at rest, only electric force will act on it, and because of this electric force, this charged particle will gain some momentum towards y-axis, and as soon as charged particle gains some velocity, magnetic force also starts acting on it. So because of these two forces, electric force and magnetic force, the path of charged particle will be something like this curve. Now we want to analyze what this curve will be and how this particle will move. So let's say at an instant charged particle reaches somewhere here. Because of work done by this electric field, electric force, this charged particle gains some velocity. It will be tangential to this path. Let's say velocity is v. Now as we know this, that magnetic force acts perpendicular to velocity. So this will be magnetic force acting on the charged particle, and electric force will act towards electric field. So this will be our electric force. So these are two forces acting on this charged particle. Combinedly, these two forces are called Lorentz force. So as we see, net force acting on the charged particle will be this vector addition of electrostatic force and magnetic force. Combinedly, these two are called Lorentz force. So there are some important points to consider about that. As we know that the magnetic force always acts perpendicular to velocity, and hence work done by this magnetic force will always be zero. So whatever kinetic energy or speed this charged particle has gained is purely because of this electric field only. So let us consider this velocity gained by this particle in vector form. Let's say we resolve this. So we get one x component and we get one y component. So this is velocity of this charged particle in vector form. Now we can analyze this Lorentz force in vector form. So what is electric force? So in vector form, this electric force is Q E is magnitude of the force. It is acting along y-axis. So Jk. And what is magnetic force? Magnetic force is formula is Q V cross B. So keeping all values, what we get is Q V is Vxi cap plus Vy j cap cross magnetic field is B k cap. Solving this will get Q and B, and after cross multiplication we will get Vx. Now I cross k is minus j and plus Vy, j cross k is I cap. So j cross k is plus I cap. Now this magnetic force is Q B Vx minus j cap and plus Q B Vx Vy I cap. So what we see here is one very interesting thing, that if you see with j cap you will get Vx, and if you see with I cap you will get Vy. This is very interesting thing here. Now if we see net force, so in net force we will get Q E j cap, this is electric force, and plus magnetic force is Q B V y I cap and minus Q B V x j cap. Now we will take I cap and j cap together. So this F net becomes Q B V y I cap plus Q E minus Q B V x j cap. And now we say acceleration is F net by m, so that is Q B V y by m I cap plus Q E by m minus Q B V x by m and j cap. Now since this acceleration can also be written as ax I cap plus ay j cap, so by comparing coefficient of I cap and j cap we can analyze that ax is basically qb by m vy and ay is qe by m minus qb vx by m. So in ax we see vy and in ay we see vx. So this is very interesting thing about this, and in some problem you will find this types of thing where with ax you will find vy, with ay you will find vx. So how to solve this problem? Now to solve this problem, what we will do is we will analyze motion along y-axis on one side and we will analyze motion on x-axis on one side. So let's start with the motion along y-axis. So if I differentiate this ay, let's say differentiate this ay with respect to time, what will we get is d by dt of qe by m minus qb vx by m. Now since qe by m is constant quantity, differentiation of that will be 0, and differentiation of vx will get differentiation of vx only. So qb by m is constant, we take it out and now we differentiate d by dt of vx. That will give us what? So let's say d by dt, and to ay we can write dvy by dt. This is ay, and now this qb by m and dvx by dt will be ax, and we know value of ax. On left side you can see value of ax is qb by m into vy. So this can be written as d square vy by dt square, and that is equal to minus qb by m into ax, and the value of ax is qb by m into vy. So what we have done is that we have converted all values in terms of y only, and this seems to be the equation of SHM minus qb by m that is equal to q by m the whole square into vy. Now I guess you have recognized this equation. This is equation of SHM. So we can write d square vy by dt square, that is equal to minus omega square vy. Now you will be familiar with this equation, where what is omega, and this is equation of SHM. So this equation is representing that velocity of charged particle along y-axis is a type of SHM, where solution of this equation which I am giving number 1, the solution of this equation is directly we know from the SHM is V naught y sine omega t plus phi. This is the solution of this equation where we have to find value of phi and V naught y, which we can easily find with the help of boundary condition. Means with the help of limits we can find this. Where what is omega? Now this is very important relation. We have to take care of this. So omega is basically QB by M. So this equation Vy is equal to V naught y sine omega t plus phi is representing that charged particle is moving, is doing simple harmonic motion along y-axis. And let's say we underline this with some another color because this is an important relation. Okay, now how to find V naught y and phi? So we know something. If you go with the original problem, we will find that at t is equal to 0 we were at the origin, and at t is equal to 0 particle was at rest. So since it was at rest, its velocity is 0. It means its Vx and Vy both are 0 at t is equal to 0. So since we know all these things, we can use these things here, that at t is equal to 0, both Vx and Vy are 0. So Vy is also 0. So as we put these two values in our equation of SHM, this is our equation where we will put these values. So at Vy will put 0. This is V naught y, and sine at place of t will put 0. So we'll get only sine phi. Now from here we can conclude that what is phi? Phi is 0. Now I'm going to differentiate this equation 2 once more. So as I differentiate this equation once along y-axis, what I will get is V naught y omega cos omega t plus phi, where value of phi is 0, I can put it directly. Now this d by dt of Vy is basically Ay. This is V naught y, and value of omega I know that is QB by M. Value of t is 0 plus value of phi is also 0, that we have already found out. Now cos 0 is 1. And what is Ay? Now we know one thing, that at t is equal to 0, Ay will be QE by M. How? How we got this QE by M? So let us analyze this. So at t is equal to 0, particle was at rest. And since particle is at rest, you can find from here that magnetic force will be 0. So at t is equal to 0, only electric force is acting on the charged particle. And what is electric force? Electric force is Q into E. So what is acceleration at t is equal to 0? It will be only, you can find out that acceleration from at t is equal to, no, so at t is equal to 0, only electrostatic force was acting, since velocity was 0, and electrostatic force was acting along y-axis at t is equal to 0. And value of that force was QE divided by M, you will get AY. So AY is QE by M. I hope you understood that how we are getting this AY is QE by M. So keeping this value AY QE by M in this equation, we will get V naught y, you will get QB by M, and on solving this equation what I get is V naught y, and V naught y is coming out to be E by B. Now this is also very important relation. So as we got V naught y, what I can write now is equation of SHM, that is Vy is equal to V naught y sine omega t plus phi, keeping phi is equal to 0, that we have already found out, and value of V naught y we have just found out E by B. So Vy is now, Vy is V naught Y, that is E by B sine omega we already know, but we'll keep it omega here only, and phi was 0. So this is your motion of y-axis, motion of charged particle along y-axis. So this is velocity of charged particle along y-axis. Now with the help of this velocity we can analyze its y coordinate, motion of particle along y-axis also. So this Vy we can write as dy by dt. Now that will be E by B sine omega t. On integrating this, we will get y coordinate as a function of time. So this is sine omega t dt. Now integrating both sides. Now as we know, t is equal to 0, particle was at origin, so its y coordinate was 0. At any time t, its y coordinate let be y. On integrating, we will get y is equal to E by B omega and minus cos omega t. This is integration. Now keeping limits, what we will get is E by B omega 1 minus cos omega t. This will be the value just after keeping limits. Now I am doing one thing, that as you see that y is equal to, this is some value. From dimension analysis I can say that the dimension of this value E by B omega should be something of distance, since y is position, y coordinate. So I am representing this E by B omega by a letter r. Let's say r is some quantity which is dimensionally it is equal to distance. So if we have assumed this, I can write y is equal to r into 1 minus cos omega t. This is y. And now what we can see is that at t is equal to 0, y is coming out to be 0. At certain time when omega t becomes pi by 2, y becomes r. And at time when omega t becomes pi, y becomes 2r. So charged particle is moving along y-axis in sinusoidal form with mean position at r, with it is moving something like this. So if we start from origin, if this was origin, so charged particle, so this is r as well as this is also r. So it is moving, we can say it is moving with amplitude of r, with lowest position 0, mean position r, and highest position 2r. So this is how it is moving. So let us first analyze motion along x-axis as well, and then we'll combine this both x and y-axis motion, and we'll finally conclude what will be the motion of charged particle. So this was all about its motion along y-axis, where we have taken y coordinate and we have taken velocity as well. Now let us move towards x-axis. So towards x-axis what we see is ax is equal to qb by m vy, but we have already found out vy is a function of time. As you can see, this is vy as a function of time. So we can directly use this vy in our equation that is on left side, ax. So we'll put this vy in this ax. So what will be our ax? Ax will be qb by m, and value of vy is e by b sine omega t. It is e by b sine omega t. So we can cut this b. Now this will be ax, and it will be qe by m and sine omega t. So we can see acceleration along x-axis is doing SHM. If acceleration is doing SHM, then definitely velocity should also do SHM. So AX, we can write dvx by dt, that is QE by m sine omega t. On integrating this equation, we'll find something. Let's see what we find. So sine omega t dt, integrating both sides. So at t is equal to 0, we were at origin. So we were at origin and our velocity was 0, and hence Vx was also 0. So since net velocity was 0, its x and y component both were 0. So this is velocity Vx. At some time, let's say our velocity along x-axis is Vx. Now on integrating this, we'll get Vx is equal to QE by m omega minus of cos omega t. This is integration. Now putting limits, what we'll find again is QE by m omega. Now converting limits, I am taking out this minus sign, and on putting limits, what we'll get is 1 minus cos omega t. So this is Vx. So this is what we have found along x-axis. And now let's see what is the value of QE by m omega. So this is Vx. So as we can see, velocity is also doing SHM along x-axis. But this type of motion is something different. It is not purely sinusoidal motion. So let us first find out x also, then we will analyze it altogether. So to this Vx, we can write dx by dt. So this, since Vx is dx by dt, which is basically QE by m omega and 1 minus cos omega t. So this dx will be QE by m omega 1 minus cos omega t and dt. Now we'll integrate this. At t is equal to 0, we were at origin, so our x coordinate is 0. At some time t, our x coordinate is, let's say, x. So after integrating, what we will get is QE by m omega. Let us put value of omega as well, that is QB by m, and on integrating we'll get a t minus sine omega t by omega, and we'll put limit as well. And after putting limit, what we will get is E by B, this is t minus sine omega t by omega, and this is after putting limit as well. So this is our x coordinate. Now what we have found about y also was this. Okay, so let us solve it further. So if we solve it, E by B omega, then we'll get omega t minus sine omega t. And if we see that what is E by B omega, so we have given name to this E by B omega. You can see we have given name E by B omega as R. So here also I will put this R. So what is x? X is R into omega t minus sine omega t. So this is our x. So finally we have arrived at our x coordinate and y coordinate. So this is x coordinate and this is y coordinate, and if you see both of them combinedly, you will find that this is a equation of cycloid. So what is equation of cycloid? So what we have found is x is equal to r into omega t minus sine omega t. So So basically is omega t is some angle, some theta, and y is equal to r into 1 minus cos omega t. So these are x and y, and if these are x and y, we'll get equation of cycloid. So to analyze this, what is cycloid, let us do one more thing. So what I can do is that, let's say x by r is equal to omega t minus sine omega t, and y by r is equal to 1 minus cos omega t. Or what you can write is x by r minus omega t, that is equal to minus sine omega t, and y by r minus 1 is equal to minus cos omega t. Now let omega t is equal to v naught. So if we do this, x by r minus v naught is equal to minus sine omega t, and y by r minus 1, that is equal to minus cos omega t, and let's say we give them name x and y. And now if you square and add both these things, x square plus y square, what you will get is x by r minus v naught the whole square plus y by r minus 1 the whole square, that is equal to 1, or you will get x minus r v naught the whole square minus plus y minus r the whole square, that is equal to r square. Now what we know is equation of circle. So equation of circle is x minus a the whole square plus y minus b the whole square, that is equal to r square. So a circle where origin are a and b, if a circle with origin a and b, then equation of that circle is what? X minus a the whole square plus y minus b the whole square, that is equal to r square. This is equation of circle. So equation which we are getting here is somewhat similar to this equation of circle, with one minor change, that instead of a at x, what we are getting is r v naught, where v naught is some velocity dimension wise. So and at place of b we are getting is r. So basically if you take a disc or a circle, and if you start rotating it with some angular velocity omega, in fact you start rolling it with some angular velocity omega, and if it is pure rolling, then its velocity v naught will be r omega, where r is the radius of this disc or ring. And then if you take any point of this ring, and if you analyze its path, what you will find is this path will move in some trajectory like this, and same is the trajectory of this charged particle, and this trajectory is basically cycloid, and this what we have found is also equation of cycloid. So I hope this problem is clear to you. Try to this problem yourself. This is one of the examples from concepts of physics by H.C. Verma. Thank you for watching video. Please subscribe this channel for more related videos.